So we have 33 people, 32 people already. Let's confirm that, still confirm that you can hear me.
Yes, sir. I can hear you.
Okay. We need to confirm that all the departments are represented. Do we have people from mechatronics? Anybody from mechatronics? Anybody from mechatronics? Anybody from telecommunication? Anybody from computer? You people are not talking.
Yes,
Yes,
sir.
sir. Mechatronics, sir.
When I ask a question, you respond to
Electrical.
me. When I ask a question, you respond. That is the only way I can confirm that you hear me. And which other department? Electronics?
So we are here, sir. Electronics is
Okay.
here.
So the lecture is, let me share my screen. So what can you see on my screen?
Physical Product Development Studio.
Okay, so that shows you can see my screen. I'll put it on PowerPoint mode. Can you see it?
Yes, sir. Very clearly.
Yes,
Okay.
sir. Very clear.
Yes, sir. We can
Okay.
see it.
I can see it very well, sir.
If at any point in time you can't hear me, you will need to signal me. My name is Engineer Dr. Ekene Samuel Mbono. The coordinator of this course is Engineer Professor C.A. Okoronkwo. And another lecturer that will take you on this course is Engineer F.I. Nwa Okolo. And we'll be working in partner with Smart World RC Limited. I will tell you their role, what they're going to help us do in this course. Now, in this course, Physical Product Development Studio, FUTO-SES 302, there are 5 basic modules we are going to cover. Number 1, we are going to cover automatic water level controller. We are going to design, simulate, and implement automatic water level controller. In module 2, we are going to design, simulate, and implement temperature monitoring system. In module 3, we are going to design, simulate, and implement radio frequency identification based attendance system using Arduino. And then number 4, we are going to implement automatic door security system. Automatic door security system. It is. that is wireless door alarm system. And then finally, on module 5, we are going to design, simulate automatic street light system. It's a semester work, so we get to tighten our belt. The way we have organized the course is such that each department will produce one copy of this project. So at the end of this semester, we have 5 departments now. So we are going to have 5 automatic water level controller, 5 pieces of temperature monitoring system, 5 pieces of RFID-based attendance system, 5 pieces of automatic door lock system, and 5 pieces of automatic street light system. So what it means is that each department will be divided into 5 groups.
Can you longer see your screen?
Yeah, I stopped sharing. I will share again. What it means is that each department will be divided into 5 groups. Is course ref for MCE here? MCE course rep or the assistant, is he here? Course rep for electronics, is the person online? All of course rep for computer, are you online? None of these people, nobody has said, is it that the course rep don't attend lectures or what? Because they're the one that will carry out these instructions.
Sir,
Electrical is online, sir.
mechatronics is around.
You say?
Sir, electrical is
Mechatronics.
electrical.
Okay, the course rep should divide the class into 5 groups. One group will be handling one project. The other group will be handling the other projects. So at the end, you will have 5 groups. Okay, electrical, how many are you in your department?
Electrical is 125.
125. So 125 divided by 5 is what? That's 25 now. Is that correct? So that's 25. So each group should be 25.
Yes, sir, it's correct, sir.
And then electronics, how many are you?
Electronics is also 125.
Anyway, I've passed the information. Somebody is saying that he can't hear anything. I think it might be from the person's location. Also, the weather is not all that friendly. Let's continue. Okay, so this is my profile. I think this is first time I'm meeting many of you. So let me just run down my profile. Mbonekene Samuel is a control system expert and RD consultant. He had his B Engine in electronics and computer engineering from Namdaziko University, Nigeria in 2005, M Engine in computer engineering in 2012, and PhD in computer and control engineering in 2017. He is presently a senior lecturer in the Department of Mechatronics, FUTO. He was the head of Mechatronics Department and also head R&D Department at the Electronic Development Institute, former Center for Adaptation of Technology, CAT, OCA, under National Agency for Science and Engineering Infrastructure, NASENI FMST. That is Nigeria now, where he worked as a senior R&D engineer from 2007 to 2014. 2009, he served with mechatronics team that automated cassava flour mill at Scientific Equipment Development Institute, Sedimina, Nigeria. In 2012, he was a resource person at IEEE workshop on robotics in Abuja, Nigeria. 2014, he served with the military research team that deployed the surveillance system of 930 military aircraft belonging to Nigerian Air Force at Air Force Headquarters, Benin, Edo State, Nigeria. In 2014, also, he received award from IEEE USA as a resource person on symposium on special topics from industries at Federal University of Technology, Owerri, FUTO, Nigeria. Ekene worked at Shell Nigeria Exploration and Production Company, SNEPCO, Lagos, Nigeria in 2015 as a PhD research intern on control system security. He has also worked in different areas of embedded and computer system designs, such as remote application-based systems, artificial intelligence systems, wireless sensor applications, computer interface with embedded systems, modeling simulation of real-time systems. He has taught and worked with Matra for several years. He is a pastor in the Redeemed Christian Church of God, 2010 to date. His areas of interest include raising young people for Christ, industrial control system automation using LabVIEW, and associated softwares and hardwares, network design and cloud management, embedded systems, wireless sensor network technologies, remote monitoring and reporting, and project management. He has more than 39 technical publications and has presented papers in both international and local conferences. Professionally, he is a corporate member of Nigerian Society of Engineers, Institute of Electrical Electronics Engineer, ISA, International Society of Automation, Ayang and the Korean. Again, is married to Ogochukwu Doris, and the marriage is blessed with 3 children. That's my profile. Let's go to the lecture. So, the weather is quite, just a minute. Okay, please confirm you can still hear me.
Yes, sir. We
Okay.
can hear you.
So the aim of this course is to design and simulate. We are dealing with module 1. We are dealing with this automatic water level controller. The aim is to design, simulate, build, and test an automatic water level control system that uses a digital or analog water level sensor to detect the state of a storage tank and automatically activates or deactivates a DC water pump through a relay with the entire control logic implemented on Arduino Uno microcontroller. So at the end of this module, you are supposed to understand the operating principle of digital water level sensors and flow switches. You are supposed to understand and configure digital input and output pins on Arduino Uno. You will understand the function of a relay module as an electrically controlled switch for high power loads. You are going to implement a simple on and off feedback control algorithm using Arduino and analyze the system hysteresis and the characteristics and explain the importance of such. Okay. So the materials for the course, you have Arduino. Can somebody read what is on the screen? Read what is on the screen. I want the class to be interactive.
We are not seeing anything, sir.
Now we are not seeing your screen again.
We are
You're
not
not
seeing
seeing
your
my screen
sir.
again?
Yes, sir.
Yes, sir.
Oh. Okay. Let me share my screen again. Can you see it now?
No, sir.
Loading. We can see it now.
Yes.
Okay, somebody should read what is on the screen.
Serial number, component, description, quantity, purpose. Under the components, we have Arduino, R3.
Your voice is fainting.
Under the component, the first device there is Arduino UNOR3. Then the description is 80 mega 328p, 16 megahertz, 5 volts. Quantity 1. Then the purpose, main micrometer. Then number 2, water level sensor. The description, resistive probe type, 3.3 to 5 volts. Quantity 2, detect water presence. Then for number 3, we have 5 volt relay module. The description, single channel and optocoupler isolated. Quantity 1. Then the purpose, switches pump power. Number 4, the DC water pump. The description, 3 to 6 volts, 120 liter per hour. So submersible, yes. The quantity is 1. Then the purpose is water transfer actuator. Number 5, power supply. The description, 12 volts, 2 ampere DC adapter or USB. Quantity 1. Then the purpose is power the Arduino. Then number 6, jumper wire. The description is 22 kWh. I don't know what that means. Then the quantity is greater than or equals to 15. The purpose is circuits interconnect. Then number 7, we have the breadboard, 830 type points. The quantity 1. The purpose, prototype, wiring base. The Sorry, number 8. We have 2 containers in bracket tanks. The material, any 1 to 5 liter container. Quantity 2. Purpose, source and destination. Number 9. USB A to B cable. The description, standard Arduino cable. Quantity 1. Purpose, programming and power. Number 10. Water hose. Shit.
Okay. So these are the materials that are required for the course. But don't buy any material yet. We will direct you on how to get this material and where to get them. Do you get the point?
Yes, sir.
Okay, so
Yes, sir.
we progress. These are actually the materials. You can see the Arduino Uno. That is the relay module. That is the 12 volts adapter. This is the breadboard, USB cable, this water level sensor, DC water pump, this is your jumper wire. These are the 2 containers, and this is adaptable box. So we move on. Now, the block diagram of automatic water level.
We are no more seeing your presentation.
You say?
We're not
We
seeing your
can't see
presentation.
your presentation.
You can't see my screen again?
Your presentation, sir, we can't.
The slide of your document, we're not seeing.
Is it that your screen is not rolling?
It's rolling. We can
We
see you.
can't
We can
see your
see you.
screen.
But we cannot see what you're explaining.
You can't see my presentation.
We can't see your screen. That's what we are trying to say.
But we can't see your screen.
Ah. Okay, let me try to share the entire screen and see whether it will be better. Can you see it now?
It's loading. Yes, yes.
We can see it now.
Can you see the change in the screen? I moved down.
Yes, sir.
Yes, sir.
So these are the items I mentioned. This is Arduino Uno. This is 5-volt relay. This is 12-volt DC adapter. This is breadboard, USB cable, water level sensor. This is your DC water pump. This is the Arduino jumper. There are jumper wires. These are the 2 containers you are going to use for as water containers, and this is adaptable box for the packaging of the electronics. So what can you see now?
Circuit simulation diagram.
Block diagram of automatic water level controller.
Okay, so this is the block diagram. Every design in engineering starts with block diagram. We start with block diagram. So you have a water tank. You have your water tank. Inside the water tank, you have 2 sensors there. One is the sensor that detects that tank is filled up. We call it upper threshold sensor. The other one detects when the water level has gone below the minimum threshold. We call it lower threshold sensor. So there are 2 sensors here. And then you have analog to digital converter, ADC, that will convert the signal or signals from this sensor, which is analog in nature. You convert it to digital equivalent because microcontroller understands only digital signals. So the digital equivalent of the analog version of the sensor values or readings will be transmitted to the microcontroller MCU via ADC. And then based on the algorithm, the flowchart, the pseudocode that controls the system, which you are going to develop, the microcontroller can either turn on the load or turn off the load. The load in this case is your water pump. The actuator is what drives the water pump. As we are going to see later, we are going to use relay as an actuator. What I said so far, is it clear to you?
Yes, sir.
Okay, so we move on.
No,
We
sir.
want to
Yes,
look
sir.
Sir,
at,
it's not clear. Yes,
it's not clear.
yes sir.
Ask your question.
I didn't get the explanation.
Explanation for,
As for this diagram, for the diagram that this one.
who got the explanation for the diagram? Can you go through it again?
Yes.
Yes, sir.
Okay, anybody that got the explanation for the diagram can go through it so that others will follow.
He said in
Now,
water tank,
in the water tank,
it
there's
has
two
sensors,
sensors.
which is one is the upper threshold sensor, and the second one is the lower
Tell us
threshold
your name and your
sensor.
department. Tell us your name and your department.
My name is Gospel China Anthony from Electrical Engineering Department.
Okay, go
Can I
ahead.
go on? Yes, he said the diagram there is a block diagram of automatic water level controller. And from the image here, we have a water tank, which has two sensors, the upper threshold sensor and the lower threshold sensor, as indicated with UT sensor and LT sensors. And then followed by the analog digital converter that sends the digital output to the MCU.
Sir, we cannot see your
I cannot
presentation
see your
anymore.
screen.
Can you see me?
I can see you.
Yes, sir.
But I cannot see
We
your
can see
presentation.
you.
You can see my screen.
Yes, we can see you.
Okay, I think I can
Yes, sir.
understand what is going on. Okay. Okay. I can understand what is going on. Can you see the screen now?
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
Okay. So, have you understand the block diagram now?
Yes, sir.
Eh?
Yes, sir. Yes, sir. It's
Yes,
clear.
sir.
It's clear, sir.
Okay. Okay, so we'll move
Sir,
on.
I have a question. Sir.
Go ahead.
Sir, in the sensors in the tank that we have the lower threshold and the upper threshold, are they reading water pressure?
No, they are not reading
I mean,
water
you're using the water
pressure.
level.
There are sensors that can read water pressure, but we're going to tell you the method we're going to use. we're going to use water conductivity. We're not going to use pressure sensor. Okay?
Okay, sir.
There are various ways that can be done, but we're not going to use
Yes, sir.
pressure
Yes,
sensor
sir. Cool enough.
because we are also looking at the cost of the project implementation. Okay, having said that, we move on. So we want to, when we are talking about water level sensor, electronic water level sensors operate by converting physical water levels into electrical signals. Electrical signals using methods like conductivity, capacitance, pressure, or ultrasonic waves. They detect, measure, and transmit data regarding liquid height, often triggering automated actions like turning pumps on or off, ensuring efficient, accurate, and often automated fluid management. Now, there are different kinds of sensors one can use. We have conductive sensors, which utilize the conductivity of water. In that case, I'm sure you know water is a conductor.
Yes, sir.
Water conducts electricity. So if you have two metals, or what generally called electrode, if you press them inside water, you automatically connected them together. So when the water level goes below those electrodes, the signal will be cut off. That's just the principle. For capacitive sensors, they measure changes in capacitance between the electrode and the container. Water acts as dielectric. So, and when water is rising or decreasing, the dielectric changes, allowing the sensor to determine the level. Ultrasonic sensors, they are not immersed in the water, they measure the distance. So, ultrasonic sensor, have you seen ultrasonic sensor before?
Yes, sir.
Okay, so they can also be used to measure water level. And then you have pressure sensors submerged at the bottom. These sensors measure the pressure of the liquid column above them. But we're not going to use that one. Then you have optical sensors. You also have float level sensors. Basically what you get in most toilet systems. So that's that. Now, these sensors are used across various industries, including industrial management, industrial measurement, fraud prevention, and water tank management. Common applications: use it to monitor liquid levels, use it in pumping systems to prevent fraud, use it in accurate liquid filling and environmental monitoring. That's water level management. Now, this is a typical sensor. This is the one we're going to use. I hope you are still seeing my screen.
Yes, sir.
Yes, sir.
Okay. This is the one we're going to use. So we're going to study that in detail. When you come to the lab, we are going to meet this sensor. And that's that. And then the sensor from the data sheet, the sensor operates between 3.3 volts and 5 volts. And the output could be variable voltage, that's analog or digital. We're going to work with the analog version. Current consumption is less than 20 milliamp, and detection range is 0 to 100% of the sensor range. Response time is less than 500 milliseconds, so that's okay. Who has worked with this sensor among you? Anyone?
No, sir.
Okay. That's why you are doing this because you are going to work with at least this sensor. Of course, as a caution, when you are connecting the sensor, you have to connect appropriately and connect the analog output to analog input of microcontroller for variable level detection, or the digital output pin to digital input for threshold detection. These are the things you are going to do practically. It's not theory. The software will also be programmed. At the end of the day, you are going to assemble, you are going to integrate the whole thing, and that's that. Now,
So I
caution,
have a question.
go ahead.
So why are we not using the digital output of the sensor directly? Why do we have to convert the analog to digital?
A digital output can only tell you that the tank is either full or empty. But analog output will help us to know whether the tank is half full, whether the tank is about to finish, the water is about to finish. I mean, you can you can say exactly where the water is. With analog output, you can actually calibrate. You can actually say that water is at say 2 cm level, 10 cm level, 20 cm level with analog output. But with digital output, you are not going to do that. Does that answer your
Okay,
question? Are
sir.
you cleared now?
Yes, sir.
Yes, I
Okay.
answered.
Okay. I mean, essentially, the digital output will only tell you that the water is filled up
Is
or
either full or empty.
is at the lower threshold. It's okay, but beyond that, I would like you to see how instrumentation works, how control system works. I mean, analog control. So that's that.
Okay.
Now, what we are going to look at two major components. Relay, this number one, and we are going to look at, for today, we are going to look at the way this relay works. Well, this is a major component we are using. And then subsequently, we are going to look at how to interface microcontroller to relay. That will be another lecture. But basically today, we are looking at relay as a component. Did you hear what I said?
Yes, sir.
Yes, sir.
We're not going to study breadboard in details. We're here by God's grace. There are several things we're still going to do together. So we will not be able to study all these things in details within a semester. We pick them. Microcontroller is almost general to all the projects. Yeah, this one is general. Sensor is specific. This sensor is specific to this project. Relay might be applicable to automatic door lock system. That should be applicable. And then breadboard is also general. As we progress, if you don't know how to work with breadboard, before the end of this semester, definitely you will know how to work with a breadboard. Should I proceed?
Yes, sir. Proceed.
Yes, sir.
Yes, sir.
Check for me how many people are in the meeting. 47.
47.
47.
Yes, sir. 47.
Including me. So we actually have 46 people. That attendance is not encouraging. Okay. So what is a relay? Who has worked with a relay here? If I work with a relay, can you indicate? Nobody.
A relay.
Okay, even if you have not worked with a relay, what is a relay? What do you think a relay is?
I have.
You say you have.
Sir, a relay is an electrical switch. A
Sir,
relay is an
can we
electrical
refer
switch.
to remote as
You say what?
An electrical switch. It's an electrical switch.
Okay.
It's a type of switch that is controlled electrically.
Yeah, it's an electromechanical switch. It has a mechanical component and also electronic component. Let's play it out. I'm trying to launch the. Can you see my screen?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, so this course is supposed to be a practical course, so we will not be doing much of talking. Now, this is a relay. Let me amplify one section.
So we cannot see your presentation.
Are you seeing my screen?
Sir, we can't see your screen again.
We cannot
No,
see
sir.
your
Eh?
presentation. Your
We
presentation is
cannot
not
see
showing.
your.
You are not seeing my presentation.
We are not
Yes,
seeing it, sir.
I think this has to do with network. But let me share again.
Okay.
Oh.
clear, clear.
Can see it now, sir.
So can you see the,
Yes,
what
sir.
can you see now?
Yes, sir. Sir, please zoom in, zoom in. Zoom out,
Eh?
sorry. Zoom out, so that we see the diagram complete.
Can you see this section of the circuit?
Yes, sir. Yes, sir.
Yes,
Yes,
sir.
sir. We
So
can
let's
see.
start from that one. This
Okay,
is
okay.
a relay. This is a relay. It has 5 terminals. It has 5 terminals. You may not realize that, but let me disconnect them. So without connection, this is a relay. It has 1, 2, 3, 4, 5. So a relay has how many, at least how many terminals?
5
Five
terminals,
to
sir.
five
5
terminals.
terminals. Among these terminals, 2 are DC terminals. Are usually DC terminals. These two, 1, 2. That is where you connect your DC voltage. These other ones are usually AC terminals, but you can also connect DC to it. This one is called normally closed, normally open. Come on. How many? What is this one called?
Normally closed.
This one,
Normally open.
this one,
So I didn't get the last one. You're not.
common,
Common.
common.
Okay, sir. Okay, sir. Common terminal.
So, why is it called common? Look at this. Let me run this circuit and close the switch. What do you notice?
There's a movement between the normal closed and normal, between the three terminals, the common, the normal closed, and the normal open.
Normally open, normally close. You can see that this one is switching between this. When the relay is
When the switch is
energized,
closed.
it switches to normally
Yes.
open. Okay?
Yes.
When it is de-energized, it switches to what? Back to what?
Closed.
So which means
Closed.
this common is actually this terminal is actually common to normally close and normally open. The principle of operation is relay is a coil, it's an inductor, and from electromagnetic induction you studied in physics. When you connect a DC, when a current flows through an inductor, electromagnetic field is formed. And when the electromagnetic field is formed, it's going to, if there is a metal there, it's going to attract it. Let me show you the what is it? Look at this. Can you see this now?
Yes, sir.
Please, what can you see? Let me be sure you are seeing what I'm showing you. What is my mouse pointing at?
We can see it, sir.
Brief electric
We can see it, sir.
Okay. So when you connect your DC supply here, this electromagnet becomes a magnetor and it attracts this ion down to attract this armature, movable metal down. It makes a contact. When you come to the lab, when the relay switches, you will just hear a clicking sound. Or even if you normally have, where can you find your relay? Where do you find relay in your home appliance?
Alarm.
Eh?
Alarm.
Alarm? Not
Yes,
alarm. I don't think it's not an alarm.
Stabilizer.
Eh?
Okay, yeah, yes. Stabilizer.
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 Stabilizer. Those clicking sound you hear in stabilizer is actually relay clicking. So when you de-energize the relay, when you remove the power source, it de-energizes, and then when it de-energizes, the magnetic field dies off, and then the return spring will return it to normal position. So you notice that this is normally open. Okay, this is common, and if there is any contact here, that will be normally closed. This is also another representation of relay. Let's go back to the simulation. So basically, this is the way relay works. You create the switch, the current flows through the coil, in this case 0.05 amp, and then you open it up, it releases. How do we apply that? Let's go over to the second one. Let's move the focus. So, can you see this now?
Yes, sir.
So this is AC source of 220 volts, 50 Hz. We want to use the relay to control this lamp. So what it means that we connect one of the terminals of this lamp to the neutral and then live. We don't, instead of connecting it directly to the lamp, we connect it through a relay. We connect the line of this AC or your socket to common such that when we now switch, if we switch, look at what happened.
Light on.
Oh, nice.
Does it make sense to you now?
Yes,
Yes,
sir.
sir.
Please tell your colleagues, my lecture, by God's grace, is not a lecture you will want to miss. I keep on saying I'm not a regular lecturer, conventional lecturer. That's why I know that I'm aware that there is no way BG Hall will contain all of you. I think you people are more than the capacity of that hall. Is that correct?
Yes, sir.
Yes, sir.
And
Yes, sir.
I have to do something that makes more sense to me. But then you notice that the attendance is just 43. Anyway, let's continue. You open it up so you can see what is going on.
Yes, sir.
Yes, sir.
We are actually using 12 volts. We are
To
actually using
control
12 volts to control how many voltage now?
220 volt AC.
220. And it can actually be reduced further if, please, if you are not talking, unmute yourself.
Hello.
We can actually, where is the noise coming from? Let me see. Please, if you're not talking, if you're not talking, mute yourself so that I don't disturb the meeting. Okay, so now I say we can also use 5 volts. If this is a 5 volts relay, we can actually use 5 volts to control it. I mean 5 volts. Can you see that? Do you see that?
Yes, sir.
So
Yes, sir. Yes, sir.
this is what we mean when we say power electronics. Power electronics. We are using electronics to control what? Power. Now we shift the focus to the third item there. We can use a relay to also control DC motor. This is a DC motor. This is 5 volts relay. Once we switch, what do you notice?
It starts pumping, rolling.
It starts moving. You can take that motor as a
Yeah.
pump, DC pump. Once you switch, it starts moving. It starts pumping. And then it stops. The automation here, when we bring in automation, instead of switching this manually, we can now write a program or design a system that will be doing it automatically. In that case, we say that the system is automated.
Autonomous.
The system is what?
Automated.
Automated. So we progress. I want to believe that you now have understanding of what a relay is. Is that correct?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. At least you have a theoretical understanding. I expect you to also have a practical understanding. You get to work with a relay, switch a relay. Don't assume by seeing it that you have known it. It's not true. Okay. Now we go back to our slide so we can make progress. What do you see? Read what you have on the screen.
Method.
Principle of operation of major component.
Relay. And the circuit diagram. Sorry, a diagram of the components.
What do you see? I can't hear you clearly.
I said methods, principle of operation of major components,
Major component.
relay, and an image of a component.
Which has the coil terminal?
Coil terminal. Okay. So these are the coil terminal. This is common, normally close, normally what?
Open.
Open. We progress. Voltage spike and back EMF of an inductor of a relay. We are coming to the practicality of what we are discussing. The voltage across an inductor, I think I should play this also to you. Let me play this first. Can you see the entire screen?
Yes, sir.
Okay. So when we run this, what is the voltage? Let me remove this one first. Based on the voltmeter and the ammeter, Let's close the circuit. What is the voltage across the inductor?
50 volt.
Zero.
Oh, sorry. Zero.
Zero.
Why is it zero?
Yes, sir.
I agree it's zero, but why is it zero?
I don't know.
I don't know.
Thank you. You don't know. Who knows?
Sir, could it be because of the diode?
Because of what?
The diode you removed.
You say?
Could it be because of the diode you removed?
Diode? Is it the diode
Yes.
I removed?
Yes.
No, it's not because of diode.
And
What is the current through the inductor?
0.25.
Yeah.
0.25. The voltage across an inductor is given by V
Shit. True.
is equal to L
True.
di dt. V is equal to L di dt, where L is in the inductance of the inductor. Now, the IDT is the change in current with respect to time. Based on this circuit you are seeing now, is the current changing?
True, sir.
Eh?
No, sir.
So what is the
No.
IDT?
No, sir. We are following now.
You are
Zero.
following now.
Zero.
So the
Yes, sir.
IDT is zero. That's why the voltage is zero. So there is the resistance. What it means is that the resistance, V is equal to IR. Is that correct?
Infinite. Yes, sir.
And if the current is not zero and the voltage is zero, what must be the value of R?
Zero.
Zero. Because the voltage, the current is not
Yes,
zero.
sir.
Current is not zero. We can see that the current is 0.25 amps. Current is not zero. So if voltage turns out to be zero and V is equal to IR, it simply means that
Okay.
the resistance of that
is zero.
inductor is what?
Zero.
Zero.
Exactly like
Zero.
So let it sink into your head today that opposition of an inductor to a DC current is equal to what?
Zero.
Zero, sir.
We follow. Thank you, sir.
Opposition. When you get a pure inductor, the opposition to the flow of DC current is always equal to what?
Zero.
Zero. Another way you can look at it is by checking the impedance formula. You always know. What is the impedance formula for an inductor? XL is equal to?
Yes, sir.
XL is equal to what?
Shit. God damn it.
XL is equal to what?
The voltage across the inductor.
No, I'm talking about impedance of an inductor. You people did is it that you didn't do impedance,
201.
and what? Resistance. Impedance. You have not come across ZL is equal to 2 pi FL.
Okay, we have, sir.
So for a DC circuit, for a DC signal, what is the frequency? Does DC voltage,
Sir,
does
repeat.
pure DC voltage, does it have frequency? The
No.
frequency, the frequency is zero. And if the frequency is zero, then the impedance of the inductor, which is the resistance of the inductor, will become zero. But let it be known to you
Yeah, true.
that anywhere you see an inductor in a DC circuit, it will provide zero resistance. It doesn't
Zero.
it doesn't provide resistance. It doesn't oppose DC. But there is something about the inductor. Watch, this is an oscilloscope. Watch now. This is an oscilloscope. Okay. Terminal A terminal, channel A is connected to this point. Y channel B is connected to the voltage across the inductor, which at this case is zero. Look at this. This is channel B, which is blue in color. This is channel A, which is it yellow? Orange,
Okay.
yellow in color. Now, watch this graph. What do you notice? What do you notice?
Which is holding.
You notice that there is a voltage spike each time this circuit is opened up. Each time this circuit is closed and opened up, there is a voltage spike. You get the point? Look at it. This can actually cause a problem in a circuit.
Sorry, sir. Did you say voltage spike?
Spike, voltage spike, S-P-I-K-E, spike, voltage spike, voltage spike, voltage,
Equal.
voltage spike. See what I mean? Sudden rise in voltage. Sudden rise in voltage. Can you hear me?
Yes, sir. Yes, sir. We are still hearing.
Okay. There's a network disruption from the other phone. So that's that. This can actually be a problem in a DC circuit where you have an inductor. If you use microcontroller, that voltage spike can spoil your microcontroller because the voltage spike will be going above level. The way to overcome it is to use what is called a freewheel diode. This diode, you connect it this way, it will reduce those spikes. Let's run it again. So let's close the circuit. Let's open it. Notice the spike will reduce. There is still spike, but it has reduced. It's no longer as big
Yes,
as it
yes.
used to
Sudden
be.
rise effective.
Just hold on. Let me turn my
Oh,
feedback. Let me turn my feedback on. Just hold on. Um, do you understand what I mean by voltage spike? Can you still hear me? Can you still
So
hear
we cannot
me?
see
yes,
your
sir.
We cannot see your
Yes,
presentation. We are
we can
seeing
hear
you.
you, sir.
Okay. Can you see my screen?
Yeah, we can see you, but not
We
your
can see you, but your
presentation.
presentation, we cannot see your presentation.
Okay. Let me share my screen again. Can you see it now?
Yes, sir.
Very clearly.
Okay. So that's that. And so you use that diode is called three-way diode. This is the summary of what we have said. Voltage across an inductor is given by L di dt. And that's that. SL is equal to 2 pi FL. And this diode that is here is called reverse bias diode, anti-parallel diode, three-way diode, catch diode, flyback diode. I normally call it freewheel. Choose anyone you like. Then as we begin to round off the lecture now, I don't know what is time now.
This is
This is 9:30, almost
9:38.
9:30.
9:38.
Yeah. So um optocoupler is used for complete isolation when you want to interface a relay to microcontroller. You don't want any spike to affect the microcontroller at all. So opto means what? Opto means what?
A con a
Light.
con so,
Light.
You
so
say?
Optics. Light.
Opto means light. Opto means
hmm.
light. So light. So when we say optocoupler, we want to connect this circuit to this circuit using light, no physical connection. And how do you do it? You use ICs called optocoupler. You can check 4N35 later, PC817, they are optocouplers. What
I
happens is
see.
that when you bias this diode, it will emit light that will bias the base of this transistor. And when it biases the base of this transistor, terminal 3 and 4 will be connected together. So whatever that is connected on 4 will come up to 3. And that is the way, basically, the way it functions. How do we use it? Look at it. Okay, let me see. Let me see if I can play this for you. Now watch this. This is optocoupler. This is the relay. Watch this now. You notice what is going on?
Yes.
You notice that this circuit doesn't have anything in common with the entire of this circuit. Look at it, see it clearly. Let me remove the connection to oscilloscope. This circuit is just this on its own, while this circuit is this one, entirely different circuits, but they are connected using light. So it's used as a protective device. If anything goes wrong with this circuit, it's not going to affect him. Basically, we use the microcontroller on this left-hand side, and then optically couple the control to the right-hand side. So
Okay.
even if there is a voltage surge, it's not going to affect our controller. That's what it means. So optocoupler is basically used for complete isolation. Complete what?
Isolation.
Isolation.
Isolation
You use it to isolate one circuit from another. Complete.
completely.
Yeah, you isolate them completely. No feedback. There's nothing like flow back. You get the point?
Yes, sir.
Yes, sir.
So that's that. We move on. So finally, how do we bring them together? Um, but this is not for today. But microcontroller, instead of, you can see I've removed the switch now. I hope you can still see my screen.
Yes, sir.
Yes, sir.
So we've removed the microcontroller, we have removed the switch and then placed the microcontroller. We have already programmed it. We may not be able to talk about the program today, but what is there is on and off program that will be toggling this pin 7 on and off. Look at it. Let me just run it. Oh, it's like, uh, oh,
CPU.
it's like I didn't save that microcontroller stuff. Let me see. I didn't save it when I prepared it. Let me see again. Ah, I didn't save it, but what it means is this. Let me open it. Let me just open it. We pick can you see the screen?
Yes, sir.
Yes, sir.
So we want to replace this with microcontroller. So I remove this and pick Arduino Uno. I pick Arduino Uno. So I pick Arduino Uno, drop it here, connect any of the pin, maybe pin 7 to that, and then I open Arduino
I
IDE. Arduino IDE. It's taking time to open. I don't know whether is it because I'm sharing my screen. Okay. Can you say Arduino IDE? Is somebody still hearing me?
Yes, sir.
Yes, sir.
Can you see Arduino IDE?
Yes, sir.
Yes, sir.
Yes, sir.
So
Of
we just
course.
pick
Yes, sir.
we just pick
On and off.
and
Blue.
pick a sample
Copy.
program there and okay, we can actually connect this one to pin 13, but we connected already to pin 7. So we make it pin 7, make it pin 7, and make it pin 7.
7.
And then we compile it. We compile it and come here, upload it here, and then we run it. Do you notice what is going on? You
No,
don't.
sir.
So
Yes, sir.
the system
Automated.
is automated now, even though we have not included the
Yes.
sensor, but at least it's moving on its own, on and off.
Yes, sir. Yes, sir.
It's like it stopped to. It's supposed to be continuous. Or is it that the program is not continuous? Let me see. Is it that the program is not continuous? Let me see. The delay is even much. Let me see.
Wow.
500. But it's a continuous loop.
Oh,
It's a continuous loop.
So that 500, is it 500 milliseconds or
500 milliseconds.
so please come again? I didn't get you. Okay, okay.
It's 500 milliseconds. Should be faster now. So that is that.
sir, does it update automatically?
You say?
Yeah.
Does the Arduino on this Pro Tools update automatically if you make changes to the code on the IDE?
Yeah, that's why I configured my own.
Okay.
Yeah. Okay. So
So, Service, I have a question.
go ahead.
So, as this the opto coupler is being automated, on the long run, will there be any damages since the switch is going off and on this one?
No, no, you can't. There's no. It will only. There will only be only that. There will only be a damage if you don't use this freeway diode.
Okay,
If you
okay.
don't use this diode and you try this kind of thing, definitely you are going to damage this optocoupler. You get the point?
Yes, sir.
Because of back EMF and inductive click of this inductor. If you don't use a freeway diode that will discharge the back EMF, then there will be a build-up here that will eventually destroy this optocoupler. So that diode there is a protective device.
Okay, sir. Thank you, sir.
So we begin to conclude practical
Service, I have a question.
application. What question?
So, as regards the configuration of the Arduino IDE and the simulation, is it something we can configure on our own?
Now you can try it out now. You have IDE now. You have the Pro Tools, right?
I have the Pro Tools. I have the Pro Tools. I don't have the IDE.
You download the IDE now. Download the IDE online.
Okay, sir.
Yeah.
Thank you.
Okay. So practical application of these things, what we're teaching you is not just theoretical stuff. This thing have been applied. It's not, you are an engineer. You also practice it in the field. Recently, we installed a lift at Anambra State. So this among everything that is there, you can see Arduino and relay module there. I hope you can see the video. Can you see the video?
Yeah, but we are not
Yes, sir. Yes,
hearing
sir.
the
But
audio.
there's no sound. Yes, sir.
Yes,
But
sir.
there's no sound.
The sound may not be there.
Okay.
There is an automated lift. door is done. And the door is open. And go in. And inside down. Back door. This is switch. Lock now. So I can now start my movement.
Wow.
Now, now I'm downstairs. The bit advantage. Waiting for the door. Now I'm out. Yeah, because the people wake up on time.
Ooh, smells pretty great.
Oh yeah, here we come on. Now, come on, this now. Let's go. Okay, so that is the practical application of what we have been taught this evening. We move on. The next lecture will be on 5th of May by God's grace. Can you still hear me?
Yes, sir.
Yes, sir.
We'll be looking at interfacing microcontrollers with peripherals, component of automatic water level control system. We'll look at the flowchart. We will look at the programming and overall simulation, and then plans for practical implementation. Tutorials. Find impedance of an inductor 10 millihenry to a DC source of 24 volts, assuming current of 2 amps is flowing through the inductor. Find the voltage spike in the circuit when the circuit is turned off. When the circuit is turned off at differential time of 0.01 seconds. I expect you to practice this and answer the question on the YouTube comments. This after this meeting, the YouTube version of this lecture will be out shortly. I expect you to go to the YouTube channel and solve this in and comment. I want to see how you want to test your understanding. Also, we are test running this approach. Let us know. I want to know your feedback on the technicality of this method. Do you understand what I mean?
No, sir.
I mean, this approach of online meeting, is it beneficial?
Yes.
Do you get
To
the
some
point?
extent.
Yes,
Yes, sir. Yes, sir.
Yes, sir.
Do you understand what is being taught when compared to the
Yes, sir.
physical
Absolutely.
class?
Yes, sir. Yes, sir. To some extent, sir.
So,
Yes, sir.
I
Absolutely.
would like to get your comments on the YouTube, which will be out, I think, before 11 p.m. this night.
Oh, sir, I thought it was 24 hours.
You say?
I was thinking the video will be downloadable by like after 24 hours.
The video will be what? Hello? Hello?
Yes, I can hear you.
Somebody was making a comment.
I can hear you, sir.
I didn't hear what you said. I didn't get what you said.
I said I was thinking the video will be downloadable, accessible after 24 hours.
No, now I'm using paid Zoom. This is not
Okay.
your normal Zoom.
Okay, sir.
I paid for the subscription, so it's not all those normal listen they will give you for free. This one is not free. And finally, there are some things coming up which I will invite you. Number one is okay, we've talked about this now. We've talked about this. So when we conclude module one, we'll get to module two. Between now and Tuesday, I want to have the list of the divisions in the department. Group A, B, C, D, E. A, B, C, D, E. That's 5 groups. You can also call it group 1 to 5. Group 1 Group 1 in electronics will be dealing with automatic water level controller. Group 1 in mechatronics will be dealing with automatic water controller. Likewise, every other group. Group 2 will be dealing with temperature monitoring system so that we'll be able to show the real practical for you. That's that. I already told you I'm a servant of God, likewise every one of you. But in the campus here, I host a program that is not denominational, call it Rivers of the Living Water. Many of you actually need to improve. You can see, as busy as I am, it doesn't prevent me from taking
Sir,
spiritual.
please, we cannot hear you clearly.
Can you hear me? Can you hear me now?
Hello, sir.
Can you hear me now? Can you hear me? Can you hear me? Can you see? So can you hear me?
Yes, sir. Yes, sir.
Okay. I said I am inviting you to this program. Where is it again? It's an online program that is interdenominational, especially for some of you that probably you are an ESCO in your fellowship, campus fellowship. Every one of us needs fire. Let me just paste the Zoom link on the comment section. Where is it? Where is comment section? Let me paste it on the comment section. You can pick it up there. It's 1 hour every Wednesday online. Yes, I said this. Can you hear me?
Yes, sir.
It's
Yes, sir.
interdenominational. It's purely interdenominational. Zoom. People are connecting from all over Nigeria, all over the world. So every one of us need or needs to carry the fire. I don't know how many of you have developed the capacity to pray. You need to develop the capacity to pray. Also, I don't know. Do you like this? You may like this thing I'm doing now. This thing doesn't come just like that. You stay in the presence of God. God gives you wisdom to execute your job in a very quiet way and a unique way. if you're a leader in the campus fellowship, your campus fellowship needs to grow. Needs to grow. One of the things that brings growth is supernatural manifestation. Anywhere there is tangible supernatural manifestation, naturally that place will grow. Naturally, people will go to that place to seek for their solution or to worship God. So I won't talk much about it, but you can join us tomorrow by somebody saying he's not hearing anything. Can you hear me now?
Sir, you're audible. You're audible. I guess from network.
Yes, sir. We can hear you.
Okay. So finally, um, before we call it a day,
Sir, I have a
this
question to ask,
program
sir.
is from IEEE.
Wait.
We are running a 2-week intensive program on advanced training on embedded system design, programming, and fabrication. Going to be hands-on. That's in conjunction with RAS, Robotic and Automation Society. The program is free, provided you buy your kit from us. How many of you have seen this flyer?
We have seen it.
Okay. We don't want to, one of the things we want to do is to raise people that are competent in this area. That's why we make it free. The only consolation we are going to get from you is that you are going to buy the kit from us. And anyway, if you check the price of kits outside, you notice that it's more than the price we are selling. We are selling 43K, that's 43,000. If you check Arduino kit elsewhere, probably online, you notice that we are selling at a very good price. We are selling at a very good price. That's just that. That training will begin next week, Monday to Friday. It will last for 2 weeks. If you are going to come, your ticket, your pass is your Arduino kit. Because we don't just want a situation, people come, you are talking, they are listening. No, it's a hands-on or it's hands-on. We are talking, you are doing exactly what we are saying. That's that. Every other thing, you can check it out when you subscribe to my channel and then like the videos that are there. If they impact you, there are wonderful, wonderful videos there that talks about fundamentals of electronics in various areas. You will see a video on resistor, capacitor, diode. Just go through and learn. And then there are some wonderful messages there that will help your spiritual life. Is there any question before we call it a day? It's 10 on the dot.
Yes, sir. I have a question concerning the program
Okay.
that is coming up. What about somebody that has the Arduino kit already? Would the person be allowed to attend, or must we buy the kit from you?
You have to buy the keys from us. Now, if we
And
begin,
secondly, the quiz that you gave.
if the person already has a kit, probably the person will discuss with us now and pay a little fee because we are going to buy food now for the training. You get the point?
Yes,
Okay,
sir.
sir. Thank you very much, sir.
Okay.
And the quiz you gave, are we meant to use the proto circuit to solve it, or are we meant to solve it mathematically?
Is it the tutorial?
Yes, sir.
You solve it mathematically and post the answer on the YouTube comments.
Okay, sir.
Solve it. Tell us where you are, your department, and tell us what you think the answer is.
Thank you, sir.
Okay.
Thank you very much, sir.
Okay, in absence of any other question now, I think we can call it a day.
Yes, sir. Thank you, sir.
Okay, good night, everyone.
Good night, sir.